Graphs of logarithmic functions. So we've done a lot of things with logs at this point. We've, converted back and forth between logarithmic and exponential form. We evaluated logarithms without using a calculator, but we still haven't seen the graph of the logarithmic function. So what we're going to do, previously we had done the graph of y equals 2 to the x back in the exponential section. Because logs and exponentials are inverses of one another, we can plot the graph of log base 2 of x, which is the inverse of 2 to the x. 2 to the x has inverse log base 2 of x. We can plot the inverse by swapping the x and y values. So remembering that the inverse inverts the x and y coordinates of all the coordinates on the original function. So here was all the work we had done before when we graphed this exponential function. So this guy right here is y equals 2 to the x. Right? He has a horizontal asymptote. Oh man, I wish I would have given myself a little bit more room on here. But he has a horizontal asymptote at y equals 0. For the logarithmic function, we're just going to take these points and flippity-floppity them. So we have 1/4 comma -2. It's like right here. We have 1/2 comma -1. Oops, right here. We have 1 comma 0. Right here. We have 2 comma 1 over 2 up 1. 4 comma 2 over 4 up 2. 8 comma 3 over 8 up 3. What you end up with here. Okay, I hate drawing exponentials and logarithms. That's actually like a really darn good one. I'm pretty proud of that. It's like the best I've ever done drawing a logarithmic function. This guy right here is y equals log base 2 of x. What you'll notice is that he has a vertical asymptote as opposed to having a horizontal asymptote. So 2 to the x has a horizontal asymptote at y equals 0, and y equals log base 2 of x has a vertical asymptote at x equals 0. One of the things we talked about when we talked about inverse functions was that they reflect over this line y equals x. And you can see that that's exactly what happened. If you look at this blue y equals 2 to the x, if you were to flip him, if you were to fold on this dotted line, and this was wet ink, if this was wet ink and you folded, it would make this shape here. So this is the exponential function reflected this way. One of the things that we know about inverse functions is that they flip-flop their domain and range. So the domain of a function is the range of its inverse, and the range of a function is the domain of its inverse. I know with the exponential function that the domain was from -infinity to infinity. And the range, remember, the y values go from 0 to infinity. Now, if we flippity flop those for our logarithmic function, the domain of the exponential is the range of the logarithm. So the range of the logarithm is -infinity to infinity. So the y values hit everything. And the range from 0 to infinity is the domain of the logarithm. So the domain of the logarithm is from 0 to infinity. There are domain restrictions on logarithms, whereas there are not domain restrictions on exponentials. So exponentials don't have any restrictions on the domain, but logarithms, you can't plug in negative numbers to a logarithm. This is an important point. What would happen if we were to do that? Well, let's say that we have log base 2 of -3. Let's say we plug in a negative number here and we want to evaluate it. We do our little loop-de-loo, start at the base, across the equals, back again. So we're asking ourselves 2 raised to what power gives us -3? And the answer is nothing, right? I can't raise a positive number to any exponent and make it negative. The only way this thing is becoming negative is if I physically put a negative in front of it, and that's not happening here. So this right here is impossible. And that's why you see over here, the logarithm, it only covers half of our coordinate space, right? It only covers from x0 and onward, whereas the exponential covered all of the domain. So this is important. This is an important fact about logarithms. All right. So it's just kind of some important properties of logarithmic functions. Let's go over them. In general, our logarithmic function looks like this: log base b of x. The domain is from 0 to infinity, and the range is everything. This is going to be true always. All right, the range is always going to be everything. Even if you've translated it, transformed it, reflected it, it doesn't matter. That's always true. This domain is going to change if you shift the logarithm left or right. The x-intercept is at 1, 0. Again, if you shift it left or right, that's going to change the x-intercept. I'm not going to make a note of that there, but if you shift this thing left or right, it is going to change the x-intercept. But in general, there's an x-intercept at 1, 0. Why? Well, if we think about it, f of 1 is log base b of 1 equal to whatever. So b to the whatever is 1. This has to be 0. B to the 0 is 1. So if f of 1 is 0, that means the point 1, 0 is on the graph of f. If we were to plug in b, f of b, we would have log base b of b equal to something. So b to what power is b? The answer is 1. B to the first power. So we have b, f of b is 1, which means b comma 1 is on the graph. And there's a vertical asymptote at x equals 0. This also changes with shifting. This will change if you shift, this will change if you shift, this will change if you shift, and this will change if you shift. Here's the basic graph of the logarithm. So on an unshifted graph, as long as the graph hasn't shifted, as long as we just have a basic logarithmic graph, There are two important points that we want to remember. We have the point 1, comma 0. We have the point a, comma 1. I want to quickly just do a little bit of a drill here. So if I have log base 2 of x, the two important points on this graph are going to be 1, comma 0 and 2, comma 1. That's our a value. And 2, comma 1. If I have log base 3 of x, those important points are 1, comma 0 and 3, comma 1. If I have log base 2/5 of x, we have 1, comma 0 and 2/5, comma 1. Okay. So it's important to know these important points for the base graph because we're going to use that when we go to transform them. This right here is the general form of a logarithm. Now the k could be at the front or at the end, it doesn't matter here, but the general form of a logarithm, y equals k plus log base b of x minus h. If you remember back from transformations, if this is our original function here, if you remember back from transformations, if we have f of x minus h, this is shifting the graph left or right based on what h is. So if it's minus, let's say 2, this would shift it to the right 2. If it were f of x plus 1, this would be to the left 1. Plugging x minus 2 into this function would make it look like this, log base b of x minus 2. So if you have x minus h here, the graph is shifting. If this is a minus sign, it's going to shift to the right. If it's a plus sign, it's shifting to the left. So if it's a minus, this is going to go to the right. If it's a plus, left. Now, when you think about this function, if you were to shift it left or right, that's going to shift that vertical asymptote the same amount, right? If we shift to the left or to the right 5 units, this horizontal asymptote shifts to the left, right for 5 units. And no longer is it at x equals 0, it would be at x equals 5. So we end up with this really important thing that the vertical asymptote is at x equals h, where h is whatever this is, the opposite sign of whatever you see inside here. We'll do some problems on it. This k right here is an up or down shift depending on if k is positive or negative. And if the outside of the logarithm is ever negative, it's going to reflect over the x-axis. Oh man, I think, hold on. I pasted something that I didn't mean to paste. All right, so let's go ahead and look at some functions, and we're going to, do I only have one page of it? I guess we're just doing one page. I think I'm also going to pull some up on Alex. Let's look at some functions. Let's talk about the transformations, the base function, and graphing. Okay. So the inside of the logarithm is really the first place we're looking because we're looking for that left-right shift. H is always the opposite of whatever number you see in there. So if you see +4, that means H is -4. That means that you have a vertical asymptote at x equals -4. It's +4 here. That means that we're going to the left 4 units. What color? Okay, I did blue. This -2 here means we're shifting down 2 units. So we're taking the graph of log base 5 of x. That's our base function, log base 5 of x. And we are going to shift it left 4, down 2. The original function, log base 5 of x, has important points that we talked about. Right? We said that there's always going to be the point 1, 0, and then b, 1. So for our function, 1, 0, it's right here. B in this case is 5. So 5, 1. Base is 5. Over 5, up 1. Maybe I'll make these green. The base function has the vertical asymptote here at 0 and would look a little bit like, oh man, like this. So I'm going to take these points. We have one here that's at, not there. We have this guy right here. And over 5, up 1. Actually going to put these in black. I'm going to be moving these. These aren't going to stay here because we have to shift the whole thing around. All right. So here's my base function. Here's how it looks originally. I want to shift this whole thing down 2 units. So 1, 2, and then left 4 units. So I'm really focusing in my head. I'm looking at this point and I'm watching this point move. So 1, 2, 3, 4. And sure enough, we said that the vertical asymptote would be at x equals -4, and there it is. X equals -4. And then, oh man, I really, really dislike drawing logarithms by hand. It's awful to draw them by hand. Something like this, right? The domain no longer starts at 0. It now starts at -4. The x values start at -4, so -4 to infinity. And then the range of all logarithms, -infinity to infinity. So let's try another one. Right. Here we have -2, means we're going to have a vertical asymptote at x equals +2. And this also means we've shifted to the right 2. There's a positive 1 on the outside, which means we are going to be shifted up 1. And then there's a negative in front of our logarithm, which means we are going to be reflected over the x-axis. When we go to plot this, we're going to go ahead and, the instructions I had given for transformations were to do left, right shift, then reflection, then up, down shift. Now, this order can be kind of messed with as long as you're careful. We're going to go ahead and you can do this for the logarithmic functions. Just you can, if you have a reflection over the x-axis, do the reflection and then shift. The base function here is log base 3. So we have log base 3 of x as our base function. That function is going to have the important point 1 comma 0 and 3 comma 1. So we have 1 comma 0, 3 comma 1, and it has its vertical asymptote here at 0. Let's make it blue. So I'm going to plot those points. We have 1 comma 0. We have 3 comma 1. And we have this original asymptote here. All right. So first things first, I am looking at each of these points and I am reflecting them over the x-axis. So the point that 1, 0, it doesn't reflect because it sits on the x-axis. This point right here was 1 unit above the x-axis. When he reflects down, he'll become 1 unit below the x-axis. So he's reflected. So we did the reflecting. Now we're going to shift right 2. So that's 1, 2. And then we're going to shift up 1. Up 1. Oh man, that all got weird. Shift right 2. Right. Shift 1, 2, and then up 1. Our graph ends up looking something like this. The vertical asymptote is at x equals 2. The domain begins at 2 and goes to infinity. And the range is everything, negative infinity to positive infinity. So let's go ahead and just look at a few of them directly on Alex. I'm going to go ahead and pause and mess around with things. All right, so this is the topic, graphing a logarithmic function and finding its domain and range. Just kind of talking about how I would do this. There's a negative in front of my logarithm. I know it's going to be shifted. It's going to be reflected over the x-axis. No left or right shifts, but there is a downshift. I know this isn't on the inside of the logarithm because it would have to be log parenthesis x minus 1 to be on the inside. It's not. There are no parentheses, so we are good. Clear. So reflection over the x-axis, downshift. So I'm thinking about my important points again. We're always going to have that for our base graph. There's going to be the point 1 comma 0. We have the function log base 4 of x. That's our base function. So that's going to give us the point 4 comma 1. So we have the point 1 comma 0 and 4 comma 1 on our base graph. And then we're going to reflect, then shift. So I'm just going to kind of hover here. So I have the point 1, 0. If I reflect this point, I'm just going to plot it for a second. If I reflect it over the x-axis, it stays in the same spot. So it's reflection does nothing, and then down 1. Done. For this point 4 comma 1, so 4 comma 1, reflect it over the x-axis. So reflect it to down here. So it would be here. If you reflect it, it turns down there. So erase that one. And then you're taking this point and moving it down 1 unit. So you'd be down 1. I can erase that one. The vertical asymptote has not been changed. It stays at 0. So we've done 2 points. We have the asymptote. If we click this, it'll graph it. For the domain, this is going to go from 0 to infinity. And then the range on all of these, negative infinity to infinity. All right, just one more of these ones. Once again, we have log base 3 of x minus 1 minus 3. So this is the right shift of 1, down shift 3. Our base graph is log base 3. That's going to have the point 1 comma 0 on it, and also the point 3 comma 1. So we would have the point 1 comma 0. It would be right here. Oh man, is it lagging? I feel like, why is that not showing? Okay, hold on, guys. Let's stop sharing. Okay, let's try this again. All right. It was like not updating the screen. So here we go. We have the point 1 comma 0. We are not reflecting it. And then I am moving it right 1, down 3. 1, 2, 3. The other point that I would have on this graph would be 3 comma 1. So that would be right here. I'm moving it right 1. Oops, that's not right. Right 1, down 3. 1, 2, 3. I know that the vertical asymptote should be at x equals 1. So there it goes. Bam. For this one, my domain is going to be from 1 to infinity. And then my range would be everything, because it always is. Bam, easy peasy. Anyway, I hope that helps a little bit. And if you have any questions, send me an email. Otherwise, I will see you guys in another video. Bye.